Today, we'll be talking about metametrics and their use in sports. First, we have to start off with what is a metric. Well, a metric is defined according to a 2024 article by Catapult as something that can help in sports by using data to help athletes and teams while training in tactics. A metric is considered one of the use of data science to present data in a comparative way to be able to analyze and help aid in any relevant fields in the metric it's referencing. Metrics in sports. Metrics and statistics have been becoming an integral part of sports over the past few years when it comes to team analysis, player analysis, and even gambling. Between the big four sports leagues themselves, they have over 1,000 different metrics that have been used to analyze teams and players. If you've ever watched sports nowadays, you've probably seen a graphic like one on the left. Now, the flaws with metrics. With a world that includes thousands of metrics, it can be difficult to know which ones are valid and which ones can be flawed. Any person that considers themselves a sports fan kind of has an idea of what they think is trustworthy and which is not. Well, even numbers can be untruthful in quantifying a player via a metric as shown in a 2021 Ringer article. With so many options at our disposal, how do we know which metrics can help us in the analysis of sports? This is where metametrics can help. First off, what is a metametric? A metametric is a tool that's used to help identify which metric is the most helpful. The point of it is also to categorize the source of variation in a metric as signal or noise. Well, what variation is there in metrics? There's three different types. Intrinsic player skill, which is an individual skill level, context, which is anything surrounding factors such as team, injury, and chance, which is just the chance of something happening that's not statistically proven. Now, what are signal and noise? It's pretty simple. Signal corresponds to variation that's key input in the decision process. Example, a player's ability to operate a given system, anything that we can quantify or be able to analyze for a metric. Then there's noise, which is a variation that we choose not to explain either because of complexity or lack of information. For example, it's a complex team interaction or an intangible that we can't measure. Now, what goes into a metametric? The equation below is the mathematical representation of the combination of player, season, and metric, which are the three variables that go into finding out what makes a metametric. When it comes to the criteria to build a metametric, it measures on three things. Discrimination, can a metric differentiate between players? Stability, can a metric be stable from season to season? And independence, does the metric rely on any other metric or any other data to form itself? These are the three criteria used to be graded to determine if the metric is helpful or not. If you think about it, it's like a grading scale where A is more helpful and F is less helpful. First off, discrimination. It's important for a metric to be able to differentiate between players, and this is where discrimination comes in. As a basis, we compare the average variability of a metric to the total between player variation of a metric. This is the mathematical equation that's used to define discrimination. Next comes stability. Stability is the most helpful when it comes to sports management. It focuses on the individual's metric variation from season to season, and it also targets the sensitivity of a metric to change due to context or skill over time. A metric can be considered unstable for various reasons, such as if it's dependent on context, like teammates or injury, or even intrinsic skill due to injury. The analysis helps describe how much we expect a single player metric to vary after removing the chance variability. Last up is independence. It's how much can a metric stand on its own. Independence helps quantify the dependencies between metrics that can help decision makers make sense of growing numbers and data summaries. Where some can be an exact formula, like usage in football, some are more complex than that. If you look at the NBA, there's a lot of player tracking data that can be hard to quantify. We present using an approach for expressing dependencies among an arbitrary set of metrics, measuring multiple player styles and ability across multiple seasons. Here's an NBA example. The chart shows stability by discrimination. If you look at 3-point percentage, for example, it's the least discriminative and the least stable. If you take a look at rebounds and blocks at the top right of the graph, they're highly discriminative and stable. If you're a 7-foot center, you're probably going to get a lot of blocks and probably getting a lot of rebounds, which means that it does discriminate towards a type of player, but it is also stable. Then there are stats like per minute, which can be more stable but less discriminative compared to total metrics, for total in a season being influenced by injury, as where per game or per minute can be identified just based on the time they play. As shown in a 2017 DeGroote journal, intuition usually matches the graph for stats and shows us mathematically what we previously assumed. Here's an NHL example. It also goes by stability by discrimination. In this case, Corsi stats are more reliable than Fenwick stats for the only reason of Fenwick stats don't include shot attempts, which Corsi stats do, which help create a more encompassing individual. You can also take a look at plus minus, which is towards the center of the graph, which is a non-discriminative stat due to the fact that the scoring in hockey can be so on and off with limited goals. What does this mean for sports? As said in a 2021 Medium article, the object of sports science data is not only to look after metrics, but also bodily changes that impact performance. The new knowledge outside of organizations, this knowledge of metrics becoming more mainstream, helps fans become more aware and critical of their analysis and where it comes from. What does the future look like? Going forward, this can be used for precise metrics and use of stability. This can help consumers and sports bettors be able to streamline research and educational purposes for gambling. And defensive stats have been hard to come by, with very few telling the whole story. It takes advanced tracking to quantify it via 2015 Harvard Journal. So we can find more stats that can be a consensus compared to stats that don't have any reliability. The conclusion is we can use metrics, and evaluating sports metrics based on stability, discrimination, and independence looks to solve the problem of overwhelming stats impacting decision makers. This allows for identifying non-reliable metrics and helping construct new metrics that are unique and consistent to athletes.